Hello everyone, Saidu here and welcome to another CCNA Cyber Ops lab. Now quickly, in this lab I will be examining the header field in an Ethernet 2 frame. I also use our mininet topology to run Wireshark in order to capture and analyze Ethernet frames lives. Now in a typical network scenario, let's say from a source to a destination, when upper layer protocols communicate with each other, data flows down the open system interconnection, or you say the OSI layers, and is encapsulated into a layer 2 frame. Now, the frame composition is totally dependent on the media access type. For example, if the upper layer protocols are TCP and IP, and the media access is Ethernet, then the layer 2 frame encapsulation will be Ethernet 2. Otherwise, it will be the other type of Ethernet header or frame. So now this information is typical for a LAN environment. Now, something to note about when learning about layer 2 concept, it is very helpful to analyze frame header information, which is what you'll be seeing in this lab. I will review the field contained in an Ethernet 2 frame, and also I will use Wireshark to capture and analyze the Ethernet 2 frame header field for local and remote traffic here using our mininet topology. Now the required resources is or our CyberOps workstation VM, which is like the most primary resources here. According to the lab guide or lab manual, they also include internet access, but it's not necessary. We are not going to use internet. Now, when examining the header field in an Ethernet 2 frame, there are some field paths that are not able to be captured by Wireshark. Such fields are preamble and FCS, which is the frame check sequence. Now, the Wireshark captured here shows the packet generated by a ping being issued from a PC host to its default gateway. Now, as you can see, a filter has been applied to Wireshark to view the ARP protocols. Now, in this particular session, the session begins with an ARP query for the MAC address of the gateway router, followed by 4 ping requests and reply. Like I said earlier, the preamble and FCS are not visible in Wireshark captured, but nevertheless, they are very important. So, like the preamble is a field that contains the synchronizing bits which are processed by the network interface card hardware. And then the destination address is just the address or the MAC address of the destination. Now, depending on the type of request or depending on the type of message, this MAC address could be a broadcast MAC address or it could be a unicast MAC address specifically to a single destination, or it could be a multicast MAC address. So the source address is also the MAC address, but this time around of the source. So the device that is initiating or sending out that request is the source now. And then the source address is the MAC address of that particular PC or host. For Ethernet 2 frames, this field contains a hexadecimal value that is used to indicate the type of upper layer protocol. So in the data field. So the type of protocol in the data field. So there are numerous upper layer protocols supported by Ethernet 2 frame. Now the most common or the most popular one are the IPv4 protocol and the address resolution protocol, which is the ARP. Now the data field contains the encapsulated upper layer or upper level protocol, the data field which is ARP in this case. And the final field is the FCS, which is a frame check sequence. Now, this is used by the network interface card to identify errors during transmission. The value is computed by the sending machine, encompassing the frame address, type, and data field. So it is verified by the receiver. A destination MAC address is the broadcast MAC address. Every other host on that particular broadcast domain will receive the message because it is a broadcast. It is like for everyone on the network. But when the destination MAC address is a unicast MAC address, that MAC address or that particular frame is now dedicated or intended for a single or a particular destination. None other devices on the network will receive the message other than the specified host. Now, question like why does the PC send out a broadcast ARP prior to sending the first ping request is simply because before the PC can send a ping request to a host, it needs to determine the destination MAC address before it can build the frame header for that ping request. So now the purpose of the ARP broadcast is used to request the MAC address of the host with the IP address contained in the ARP request. From picture here, the source MAC address is this, the vendor ID which is the organizational unique identifier of the source network interface card. In this example, it is the Intel Core or Intel Corporation. Now you can always identify the organizational unique identifier because it is the first three octet of the MAC address. And then the remaining part of the MAC address represent the serial number of the source in network interface card or destination interface card. Now let's use Wireshark to capture and analyze Ethernet frames using or from our mininet topology. I'll simply log into my system, CyberOps. I'll go to my terminal, enter this sudo, and then run this topology.py, then specify or enter the password for the analyst user. Now at the mininet topology or at the mininet prompt, I'll now enter this xterm h3 to launch my h3 or host 3. Now to find out the IP address on this host 3, simply enter ifconfig from the command prompt there and see that the IP address is 10.0.0.13. Now to view the default gateway information on host 3 or the H3, I'll now enter or use this command netstart space -r to view this. So now we can see that this is the information that we got from the netstart command. Now we want to test out things from scratch. So now to do that, I'll try to delete all the ARP cache. Now from the terminal, I'll enter this command ARP space -n to display the content of the ARP cache. Now to delete any existing ARP information in the cache, or simply use you simply need to use ARP-D space followed by the IP address. Now you have to repeat this until you delete all the content of the cache. Now in the terminal window for node H3, I now open my Wireshark using this command Wireshark-gtk and then initiate ping. Now after launching the Wireshark, now select the interface that I want Wireshark to be capturing. The first interface here, then start, then go to the prompt of the host 3 or H3. First I'll now ping the default gateway, which is 10.0.0.1. Now after capturing that, I'll now stop it and then filter it to display only the ISCMP traffic. I know by now we have been familiar with the Wireshark interface. Now it has been divided into three sections: the packet list pane, which is the top here, and then the packet details pane, which is the middle, and then finally the packet byte pane, which is the bottom. Now from the packet list pane, which is the top section, and then click the first frame listed is showing an echo ping request. Now I will examine the first line in the packet details pane, which is the middle section. Now this line displays the length of the frame, which is 98 byte from this example. Now the second line in the packet details pane shows that it is an Ethernet 2 frame. So we now have the information like the source and destination MAC address, which we can see here. Now I can click the arrow at the beginning of the second line to obtain more information about the Ethernet frame. Now we get to see the type of frame that is being displayed, which is the IPv4 frame type. Now the last two lines display in the middle section provide information about the data field of the frame. Now we got to see the source and destination IP address, which is the source is .13 and the destination is .1. Now you can click any line in the middle section to highlight that part of the frame in hex and ASCII in the packet bytes pane, which is like the bottom section. Now when I click on the next frame in the top section to examine it, I'll now see that it is an echo reply frame. The one we saw earlier, it was an echo request. Now this one, the second one, is an echo reply frame. Now what you notice is that the source and destination MAC addresses have reversed because this frame was sent from the default gateway router as a reply to the first ping. That is, as a reply to the request from H3 or host 3. Now click start captured icon to start a new Wireshark capture. This will now I'll get this pop-up window asking if I would like to save the previous capture. I'll just click continue without saving. Now in the terminal window of node H3, send, I'll just enter this ping dash C5, and then this destination address as 172.16.0.40. Now, after sending out this, I'll now go back to my Wireshark, click stop capturing packet, and then filter it to ICMP. Now, in the first echo, which is the ping request, the source MAC address will be the MAC address of the PC or the sending PC, which is host 3. And then the destination MAC address will be the destination MAC address of the default gateway. Instead of having the MAC address of that destination 172.16.0.40, now the MAC address will be the MAC address of the default gateway. Now checking information of like the IP address of the PC will still be the same IP address, which is 10.0.0.13. And then the destination address will now be 172.16.0.40 instead of having the destination IP address of the default gateway. Now have the correct or the actual IP address of the destination. Now, comparing this result with the one we saw earlier, the only address that changed is the destination IP address, which is 10.0.0.1, and now it is 172.16.0.40. Now, the main reason why the destination MAC address remained the same, which is the MAC address of the default gateway, is because layer 2 frames never leave the LAN. Now, whenever a ping is issued to a remote host, the source will use the default gateway's MAC address for the frame destination. So what the default gateway does is it receives the packet, strips the layer 2 frame information from the packet, and then create a new frame header with the next hop's MAC address. This process continues from router to router until the packet reaches its destination IP address. Alright, that is it. That is a quick demonstration on how to examine Ethernet 2 frame using Wireshark. I hope you learned something from it, and I will see you in the next one. Thanks.